Hello all, in this video we are going to watch the demo of text similarity using Hugging Face models. You already know how to go to the Hugging Face. So I went to the natural language processing and selected the sentence similarity. If you notice, it pops up these models. So we are going to use these top two models. One is sentence transformers, all mini LM, L6 version 2, and BGEM3. Okay, so we are going to see these two models in the demo. Okay, so let me go to my GitHub collab. Um, So text similarity, what is the purpose of having the text similarity? Text similarity would help you to identify whether both the texts are same or not. So one such example is Turnitin website to know whether it has been, whether you submitted the same content or not. So that is a very common example that you can think about. Another example that you could be able to see, or another application, is in the search engines. So it helps to rank. If you type something that is a text, and that text should match with the Google search engine and able to pop up the results related to your search. Okay, so search engines, plagiarism detection, any type of recommendation systems based on the content that you are going to give, able to match the similar text, and then chatbots or virtual assistants um, able to identify if too many people are providing the same type of questions or same type of questions that they're asking the chatbots or virtual assistants. Okay, so how does this is working? Okay, so basically we are going to use these models and able to get the embeddings first thing, and then find out the cosine similarity between those, between those two sentences after converting that into the vectors, right? So because sentences cannot be understood by the computer, only the vector representations would be understood by the computer. In order to find same or not, we could be able to identify if the cosine values are um, if the cosine similarity is 1, you can say that the two vectors are same. And if it is 0, you could say that the two vectors are perpendicular. If the cosine values is a negative value or a -1, you could say that the direction is opposite direction. Okay, so for this, the requirements are transformers, sentence transformers, PyTorch. So basically, these are the libraries we need to use and we need to install. We would be using scikit-learn as well to compute the cosine similarity between the two sentence embeddings. So let's go ahead and install these first, importing the transformers torch modules. And then get your API Hugging Face, that's common, your API key, and get the deep learning model, and you load the deep learning model. So and you would be able to get the tokenizer to divide that into tokens and able to get the embeddings. And using this tokenizer, you would be able to get the understandable format, and then apply the deep learning models, get the embeddings, and finally cosine similarity. Okay, so first thing is install transformers, install sentence transformers, installing torch, and then importing appropriate packages here. So importing auto model, auto tokenizer, and scikit-learn also, because to find out the cosine similarity there. And we have provided you what is auto model, what is auto tokenizer. These auto models would be able to load the pre-trained models. Auto tokenizer help you to divide the given sentence into the tokens. Um, you would be also doing the OS, which is kind of like a system environment, helps you to develop the apps, GenAI apps, using environment API key. We are going to copy paste your key there. And we would be using the model here, which is sentence transformers, and then we will be using paraphrase. Mini LM L6V2. So here this is a model name, and we have been provided different parts of the model. So I mean, it's very obvious. Paraphrase would be able to talking about that model would be paraphrasing the English text or sentences. Mini LM is the effective version of the BERT. L6, that refers to the sixth layer of the neural network to process the computation. And then the fourth part is the version of it, which is second version. Okay, so we are using the model name and we are passing that mini LMV6 L6V2, and we are using auto model and then pass. We are using where is this? Yes, it's here. Okay, we are using the model name. We stored that in a model name and then passed it to the pre-trained model here. That is from auto model. Okay, so you are getting the tokenizers. Basically, these tokenizers would be able to help you to divide, and you need to pass the input. Let's say the sun is shining brightly, the weather is sunny today. Okay, so how much is similarity here? So basically, I could say sun, sunny, is the. I mean, it's very similar, right? It's exactly the same. Sun and sunny is a little bit different, but shining we do not have. We have brightly, but it is today. But kind of like a the meaning is same, even though if you change the words, the meaning is same, right? So let's see what we are going to do first. We need to tokenize them with the sentence 1 and sentence 2 as the first parameter. Returns tensors. So this would be able to provide you the format of the tokens, and PT represents the PyTorch. So we want to truncate. Truncate means basically chopping off the data compared that way do not exceed the maximum length that the model can handle. So that means if you provide like a 10 pages, definitely the model won't accept, so your 10 pages and then the 10 pages of website if it wants to compare. So in order to avoid the error, we would be truncating. That means instead of pages, it may take a sentence or a paragraph. And we would be padding that. So for example, if you are giving one sentence comparing with one paragraph, so that means this one sentence would be padded up with some blank spaces or null characters or whatever it is, equivalent to the paragraph, okay, the size. Okay. So, and then we would be using these two things to unpackage the tokens from the model. Okay, so which are two asterisks. We are going to get the embeddings here. So embeddings, so last state, finding the dimension 1, detach, and using the numpy as well. Okay, so I would recommend even you to even print these embeddings or even print the similarity scores, how you are able to see. Okay, just use print statement or in this print embeddings, print similarity score. So similarity score is fine by using a method called cosine similarity. This is getting from the scikit-learn where we have imported already. Okay, so embeddings of 0, embeddings of 1. So basically these are the embeddings of the first sentence, embeddings of the second sentence. Okay, and then you would be rounding the similarity score with the 2 decimal values. Okay, and for this similarity score, you are going to get the similarity score that you are going to get for this example is 66%, which is 0.66. Okay, so this is one example that we are comparing the similarity scores between two vectors or two sentences. So here, so this is testing the source code on different multiple sentences here. So whatever you see, it's exactly the same that we have written the code on an individual line. Okay, so we have the model name. Using the model name, we are passing that to the auto model pre-trained and then pass the tokenizer, right? So this is on this, and we provided two models here. I would recommend you to comment the first model and comment the second model and see how it's performing. But the inputs are different. So this is these are the sentences that we have given. Now the output would be comparing sentence 1 to sentence 2, sentence 1 3, sentence 1 4, sentence 1 5, and then different combinations here. 2 2 1 is already done, 2 2 2 3 2 4, and so on. Okay, so same code with different sentences taken as input. You're returning the PyTorch, truncating, padding those, unpackaging the tokens so that you could be able to understand, getting the embeddings, finding out the similarity scores of those embeddings, getting for the 2 decimal points. Okay, and then since you have several combinations here, you are using a for loop to iterate that, print the similarity score of pair 0, pair 1, and so on. Okay, and these are the scores for pair 1. The pair 1 is it's shining brightly. The weather is today sunny. So now it shows 7.72. Maybe this is doing it on a different model. Okay, you need to double check that. So I love to go to score 0.12. Okay, so this one. Let me run this here for you, in this, the similarity scores. So basically this one is for the first model itself. Earlier we got, why we got 1 here? Okay, I might have changed the input. See, let's see. I have printed some similar vectors here. So just printed it and see what you get. Where are the inputs here? Let me scroll down a little bit. Now input should be on the top. So let me scroll using this one here. Okay, so yes, so I have sun. The sun is shining brightly. The sun is shining brightly. Both sentences are same. That's why I get, the similarity value, the cosine similarity value is 1, positive 1. Where is that? It's a 1, 100%. Okay, so if it is 1, the two vectors are identical or same. Okay, so let me go back and change the input to this, and I want to see why this is coming 0.66. I think I need to run all these once again, I guess. Make sure you run every step, otherwise, I mean, these are the values that you could be able to see. Okay, as a part of your assignment, you need to explore more on this and understand what are these happening. I mean, how these are generating and all. Okay, now it shows 0.66. So we are using same paraphrase mini LM, but we get 0.72 here. That is interesting. Right? So let me go back and see. I think we had today in the past also, right? So is yes capital there? It should not matter. Capital, uppercase, lowercase. No, it's exactly the same. Okay, so yeah, maybe you need to explore why the model is giving two different values like that, same model. And I'm uncommenting the previous, uh, a different model, and commenting the previous model, and able to see what I get here. It's running. It takes time, I guess. So would you agree if these two sentences are 66% equal or 72% equal? So but the thing is that same model is giving that. I would recommend you to explore on that. Okay, and this model is giving 88%. Okay, so I think your goal is to do some analysis, which model is doing what, why it is able to provide. If it is with the more sentences, it might be providing a different, so come up with that analysis and present your results. Okay, so I think that's all I have for you in this video. Okay, thank you.